Pot Still Distillation process. During this video, we will cover a little bit more about our pot still distillation process to create quality brandy. Our focus will be on what distillation is, how the distillation process works, describing the distilling equipment specifically focused on the pot still, explaining the components of a pot still, and looking at the two stages of distillation to distill quality, unmatured pot still brandy. Distillation definition. The distillation process is used to separate ethanol and water, or volatiles and non-volatiles from each other. In the distillation of wine, various desirable and undesirable compounds must either be partially retained or removed. Distillation is used to separate two or more liquid compounds based on their boiling points. This works on the principle that alcohol and many other flavor compounds boil at temperatures lower than water, and that ethanol boils at 78.3 degrees Celsius. Distillation of wine to brandy. The separation of ethanol and water is not the only factor in the distillation of wine. Various desirable and undesirable compounds must be either partially retained or removed. Distillation takes place primarily according to two methods, namely discontinuous or batch distillation, which pot stills are used for, and continuous distillation, which column stills are used for. The former is used in South Africa and Cognac, and the latter is used in California. Armagnac is distilled according to a system that includes both above-mentioned methods. Description of a pot still. There are multiple types of pot stills, namely Saval, John Doerr, Herman, other locally designed ones, and more. The size of the pot still is only important from an energy management perspective, and to ensure variety of styles and amounts of liquid contained, like plus minus 900 liters up to 40,000 liters. Depending on the size, different risks will arise. A burnt or scorched character of the post still can be caused by too much lees in the wine in conjunction with heating that takes place too quickly, and is usually a risk when operating larger pots. Larger pot stills will usually be used for first distillation, and relatively smaller pots for second distillation. Pot stills are generally manufactured from copper. This is because sulfur compounds deposited as sulfides are present mainly in copper condensers. It is a good conductor of heat. Copper is easily malleable, resistant to corrosion, and acts as a catalyst for reactions between wine components. The length and shape of the still head determines the degree of rectification. There is usually not much rectification in pot stills, but different types of pots do present different degrees of rectification. Preheaters are used for practical and economic reasons, like saving on cooling water and steam. They can also have quality advantages regarding burning of lees deposits. Heating generally occurs by using indirect steam. Open fires were originally used in cognac, but have been replaced by mainly gas or steam. A pot still generally yields a distillate with many secondary compounds, and thus yields a product with a complex composition. Components of a pot still. A pot still consists out of the following components. The cooking pot. This is usually manufactured from copper due to it enhancing the quality of the product and because it can handle high heat. The rebate wine or low wine is pumped into the cooking pot, and heating is done mainly through steam or gas. The alcohol evaporates and moves upwards to the mantle. The mantle. The construction of the mantle varies from one pot still to the next, depending on the amount of reflux or rectification that is required. This is normally also manufactured from copper. Some of the vapor condensates when it comes into contact with the copper and drops back into the boiling pot. The most volatile vapor moves into the mantle through the vapor pipe and preheater and into the condenser. The preheater. Most pot stills are fitted with preheaters for practical and economic reasons. The vapor that is distilled is used to preheat the next batch of wine, and parts of this vapor is also condensed in this process. The condenser. This is normally constructed out of a cylindrical container through which cold water is circulated. These condensation pipes are also manufactured using copper. When the vapor condensates within the copper, they react to compounds in the distillate, with sulfur compounds deposited as sulfides. This forms components or deposits which cannot be mixed. The condenser condensates and cools the alcohol vapor to approximately 25 to 35 degrees Celsius before it flows to the spirit safe. The spirit safe. The spirit safe is where the quality and strength of the distillate gets measured and is normally fitted with a hydrometer. The pot is regulated according to the hydrometer or the temperature probe in the mantle. The spirit flows from the spirit safe to other various tanks. Pot still distillation. Pot still brandy is distilled in 2 stages. The first stage is the distillation of wine to low wine or raw brandy with an alcohol content of about 28 to 30%. The second stage is the distillation of low wine to pot still brandy with an alcohol content of no more than 75%, as per Act 87 of 1980. Pot still distillation, Stage 1. The first distillation can be regarded as a concentration process and lasts about 6 to 8 hours. The low wine is unfinished, often still displaying a wine-like character, and it is not as pure as we know brandy to be. However, it is now protected against microbiological spoilage if it is not immediately distilled to pot still brandy. The volume of raw brandy is approximately 1/3 of the original volume of wine that was at the start of the process. The volatile components have been separated from the non-volatile components and most of the water. Pot still distillation, Stage 2. The second distillation is a slow process that lasts approximately 10 to 12 hours. Exact conditions depend on the type of pot, heating configuration, the starting temperature, as well as the distiller. The product is refined during this process with the low wine separated into 3 consecutive fractions during distillation, namely heads, heart, and tails. Stage 2 distillation. Heads. This happens in the first 15 to 20 minutes and makes up about 1% of the starting volume. Heads also contain high concentrations of valuable esters. Coolers are washed by heads, the fatty acids that remained behind after previous distillation is rinsed off. Heart. The heart section lasts 6 to 8 hours and is referred to as the soul of the wine. This contains all the fruity and herbaceous flavors that form the basis of the character of the brandy. It contains higher alcohols, esters, and some short to medium chain fatty acids. The heart section, or the heart of the brandy as we refer to, is the only part of the distillate captured and used for maturation. Tails. The tails last 2 to 4 hours. Switch over from the heart section usually occurs at 55 to 60% alcohol by volume. This has longer chain fatty acids, soapy and impure characteristics, and is not desired in brandy. Factors that will ensure a good quality unmatured pot still brandy. Using a good quality base wine. Having a copper pot still in the distillation process. Having enough cooling capacity. our distiller and fraction control, and of course a burning passion for distillation.